The Fibonacci Sequence by Alicia R. Swapi 11.
Good day everyone, my name is Alicia Arsua from PY11 and now I'm gonna tackle about the Fibonacci sequence. So at first, we should know what is the Fibonacci sequence. The Fibonacci sequence is a set of integers, the Fibonacci numbers, that starts with 0 followed by a 1 and then another 1 and then by a series of steadily increasing numbers. The sequence follows the rule that each number is equal to the sum of the preceding two numbers. The Fibonacci sequence begins with the following 14 integers, which is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and 233. Each number, starting with the third, adheres to the prescribed formula. For example, the seventh term number is 8 is preceded by the 3 and 5, which is add up to 8. The sequence can theoretically continue to infinity using the same formula for each new number. Some resources show that Fibonacci sequence starting with 1 instead of 0, but it is fairly uncommon. Calculating the Fibonacci sequence. The Fibonacci sequence can be calculated mathematically. In this approach, each number in the sequence is considered a term, which is represented by the expression of Fn. The n reflects the number's position in the sequence starting with 0. For example, the sixth term is referred to F5, and the seventh term is referred as F6. Using these numbers, the Fibonacci sequence can be defined by the following three equations. F0 equals 0, which applies only to the first integer. F1 equals 1, applies only to the second integer, while the Fn equals Fn minus 1 plus Fn minus 2 applies to all other integers. The first two equations are essentially stating that the term in the first position equals 0 and the term in the second position equals 1. The third equation is the recursive formula, which means that each number of the sequence is defined using the preceding numbers. For example, to define the fifth number, which is the F4, the terms F2 and F3 must already be defined. These two numbers, in turn, require that the two numbers preceding them are already defined. The numbers continuously build on each other throughout the sequence. The following table shows that the position of each term, along with its Fn value and Fibonacci number, starting with the first term and ending with the 14th term. You can try out the formula yourself using the table to find the sequence numbers preceding the target term value. For example, the following calculation finds the Fibonacci number for the term in the 10th position, which is the F9, is equals to F9 equals to F9 minus 1 plus F9 minus 2 equals F8 plus F7 equals 21 plus 13, which equals to 34. The challenge with a recursive formula is that it always relies on knowing the previous Fibonacci sequence numbers in order to calculate the specific number in the sequence. For example, you can calculate the value of 100 term without knowing the 98 and the 99th term, which means it requires that you should know all the terms before them. There are other equations that can be used, however, such as Binet's formula, a closed form expression for finding Fibonacci sequence numbers. Another option is program the logic of the recursive formula into application code such as Java, Python, or PHP, and then let the processor do work for you. That's all. Thank you.